Hello Year 9, this is your next remote learning video. You've uploaded some fantastic work looking at those exam questions and marking them, a lot of you, which is absolutely brilliant. Now, some of you are finding this quite challenging, doing all this work remotely, showing this independence, and it's hard, it is tough, okay? Now, your teachers understand that it is difficult. We know that it is hard, okay? So if you're really struggling to complete a task, okay, and you've already spent a good bit of time on that task, and you're worried about not being able to submit it and it's not good enough, so just jot a note on whatever that piece of work is and say, I spent 50 minutes on this task, and that's where I'm at. Okay, this is what I've been able to do in this hour. Okay, and your teachers will understand that. They'll get it. Okay, so don't stress too much, or try not to, and try and keep control over what you're doing. Okay, plan in the day when you're going to do different lessons and different tasks. As I said brilliantly on the exam questions, there's one question I'd like to go through in a little bit more detail. I think it's the hardest of the questions. Okay, so I'm just going to change to the exam page. Okay, so I've got both the question and the mark scheme up here. Now remember, when we're setting these exam pro questions, you can click on the question tab, okay, or you can click on the mark scheme tab, okay, and it's hopefully quite straightforward. You don't have to be able to print these out. You can do it on a piece of paper, you can do it on a scrap piece of paper, you can do it however it'll work. You don't have to print them out. If you don't have a printer or enough paper, that's fine. You can just jot down the answers on a piece of paper, okay, any piece of paper, the back of an exercise book, that's fine. Okay, and remember, you can just click that mark scheme tab to find it. Now, the question that I thought was the toughest was the 6 marker, okay, where it's this question about what type of energy resource this farmer will use, whether it's going to be wind or it's going to be biogas. And you need to evaluate the advantages and disadvantages of the two methods of generating electricity. Okay, so to get a good mark on this, you're going to have to write a couple of advantages about biogas, a couple of advantages about wind turbines, and then say which would be the best. Conclude with a reason which system would be better for the farmer to buy and install. Okay, and on the mark scheme side, they give lots of different bullet points that are marking points. Okay, these would be typical sentences that an examiner will be looking for in answering your question. So things that you could write about biogas, it's renewable. Okay, you can write that for both. It gets a mark. Okay, so even if when you come to your exam and you have a massive meltdown in the middle of your paper, hopefully that doesn't happen, but if you did, okay, just writing down biogas is renewable and wind power is renewable will get you into the level 1 bracket. It will get you into 1 or 2 marks, probably 2 marks if you write it as a full sentence. Okay, so there's lots and lots of marks to be gained from answering these questions. Okay, even putting something, putting a little bit will get you some marks. Okay, I personally think it's easier to get 1 or 2 marks in these 6 mark questions than it is for any of the more challenging calculation questions. Okay, I think it's a lot easier to get those first couple of marks than it is to get some of the calculation marks. Okay, so you need to put things like it's renewable, and it's a concentrated energy resource. Okay, it's cheaper to install, it's got a cheaper startup, which means that it's got a shorter payback time, the time it takes to recoup your investment. Okay, there's no transportation costs for fuels. It does contribute to greenhouse effect because you are burning a fuel, but it is renewable, so you're taking that carbon back out of the atmosphere. You have all these different types of points that you can put in your answer, and then you need to say which is the best. Now, I would say it's probably biogas is the best because it's cheaper to install. Okay, it's got a continuous energy burn. Okay, it's more reliable than wind in this situation. So there's going to be days where the farmer will need to use electricity, but it's not a windy day, so they're not able to generate anything. Okay, it will give the farmer more control if they used the biogas generator. Okay, right, now this week we're moving on. We're still on the energy topic, and we're going to be looking at efficiency. So you need to be able to know and define what efficiency means. You want to be able to explain some of the different ways you can transfer energy and how it's wasted, okay, by mechanical processes. So what are the different ways you can waste the energy? How is it wasted? And you want to explain some ways of reducing unwanted energy transfers in mechanical processes. Okay, so we've already looked a little bit about efficiency when we started to look at energy transfers, but I want to really focus and get it clear in your head. So what is efficiency? The efficiency of a device is a way of saying how good it is at transferring energy as a useful output. So how much of the energy is being used for the thing that the machine is supposed to be trying to do. Okay? Okay, the efficiency of a device is given as a number between 0 and 1, or as a percentage from 0 to 100%. The higher the number, the more efficient it is. Okay? So if it's at 0, it will waste all of the energy transferred to it. If it's at 100, all of the energy will be useful. Okay? In reality, you will not get devices that are 100% efficient. You might get some things that are incredibly efficient. It might be 99.9999, can be incredibly efficient. They tend to be things like heaters, because nearly all of the energy transferred can be transferred as heat. Okay, that's normally the way devices will lose energy through heat. But if the function of the thing is a heater, it's quite easy to get a very efficient device. Okay, but it won't be able to be 100% efficient. Nothing is 100% efficient. There is always going to be some wasted energy. Okay, it's a measure of how much useful energy we get out compared to what we get in. So if I've got a lamp here, we've got energy in, okay, in this case would be electricity, and energy out, and wasted energy out. Okay, so in this case, because it's a lamp, the function of the lamp is to give us light so we can see. So the useful energy is the light energy. The wasted energy is the heat that the lamp gives off. Okay, we need to know how to calculate efficiency. Okay, you need to know this equation. You need to know that the efficiency equals the useful energy transferred by the device divided by the total energy supplied to the device. Okay, you can write that more briefly as the useful energy out divided by the total energy in. And I've got an equation triangle here that can help you rearrange. Okay, so if I'm trying to find out what the efficiency is, I'd cover up efficiency and I've got useful energy over total energy. Or if I wanted to know what useful energy is, I need to know the efficiency and the total energy. I'd cover up useful energy, and I'm left with efficiency times by total energy. Okay, you need to be able to do these calculation questions. Okay, there's lots and lots of marks available on your test if you can remember this equation and apply it. Okay, and if you get good at it, if you practice it, and you become quite confident with it, they're easy marks. They really are. Okay, but it does require a little bit of work on your behalf. You need to know that equation, you need to learn it, you need to practice it. Okay, so there's a couple of things that you need to think about and you need to be aware of when you're using the formula. Okay, the useful energy transferred by the device is always less than the total energy supplied. Okay, every time. The useful energy is always less than the total energy. Okay, that means that the device can never have a number bigger than 1. Okay, because it's a fraction. Okay, if this is always going to be a bit smaller than this, this has to always be less than 1. Okay, so if your calculation goes above 1, something's gone wrong. You've used the wrong energy somewhere, or you've rearranged wrong somehow. Okay, the efficiency can never be bigger than 1. If you calculate with a greater than 1, or calculate an amount of energy useful that's bigger than the total, something's gone wrong and you need to check your substitutions, you need to check your calculation. Okay, check you used the calculator correctly, check you put in the right numbers of the calculator, all these kinds of things. It's a trick that you want to be aware of. Now, I've got a couple of practice questions. So we've got a device that transfers 30 joules of useful energy. The total energy transferred by the device each second is 50 joules. So we can just do 30 divided by 50 to get us an efficiency of 0.6. You could also write this as 60% by timesing by 100. Okay, so all we're doing is taking the useful energy and dividing by the total energy. Okay. Next, calculate the efficiency of this heater. So this is where it gets a little bit more. It can show you how efficient heaters can be. So if I've got 100 joules of electrical energy input, one's transferred by light, as the heater glows a little bit, 4 joules by sound, because it has a little buzz, and 95 joules is heating. Okay, what do you think? What could be the answer? Pause the video, see if you can calculate. What is the efficiency of this heater? Okay, hopefully you've got that answer written down, showing all the working. Okay, all we're doing, we've got the total energy going in as 100. Okay, 95 is the useful, because the idea of a heater is to give out heat. So we do 95 divided by 100 gives 0.95. Okay, you could also have 95% by timing by 100. So incredibly efficient. Okay, you need to check. It's the last one, forgot that. You need to check that it is below 1. Okay, is it less than 1? Yes. I haven't made a single mistake. Okay, now your tasks, year 9, I've got these 4 tasks. Okay, I've got grade 4, grade 6, and grade 8. So for grade 4, your muscles waste about 75 joules of energy for every 25 joules they convert into movement. How efficient are your muscles? Grade 6, an electric fan has an efficiency of 80%. If it produces 120 watts of useful kinetic energy in the air, how much power is it using? Compare light bulbs and kettles in terms of energy transfers and efficiency, and illustrate your answer with diagrams. So you've got these 3 different tasks. Okay, now if you're confident with your energy, okay, maybe start with task 6. Okay, if you're incredibly confident, maybe start and just go straight on to task 8. Okay, if you're really, really confident. I'm not sure if you should do that, but if you're 100% there, give it a go. Okay, or if you want, you know what, I'm not 100% sure on what's going on here. I want to do my practice. Grade 4 is where you should start. The majority of you should start on that red box. Okay, and I want you to spend about 20 minutes, maybe 30 minutes, working your way through these questions. Okay, if you finish this in 2 minutes, do the next one. If this is going to take you 15 minutes, okay, and you do a really good job of it, that's okay, fine, move on to the next one. You might not finish grade 8. Okay, but I would spend 20, 25 minutes, maybe 30 minutes working on these questions. Okay, my next slide is going to be the answers. Okay, so what you want to do, you want to pause the video here, you want to take a screenshot, or you want to write down the question, whatever it is, you want to pause the video and get ready to answer these questions. Okay? Okay, hopefully you spent that last 20 minutes working your way through as much of this as you can. The next slide contains my answers. Okay, so the next slide shows this. Okay, so for that first question, the total energy transferred is 25 joules plus 75 to give me 100 joules. That's the total energy transferred. Okay, the efficiency is 25 joules divided by 100, give me 0.25. Checking it's below 1. You can also write 25%. So if you've done this, showing it working, give yourself a couple of tips. For 6, the total power in equals the useful power out, okay, divided by efficiency, which equals 120 watts divided by 0.8 to give me 150 watts. Okay, now notice the watt, this is power, it's not energy. Okay, you can use total power transferred divided by useful power transferred in the same way as useful energy and total energy. Okay, because power is just energy per second, as we've looked at before. Okay, so your answer is 150 watts. Give yourself a couple of ticks for that if you got it right. And for the last one, a light bulb, here's my answer. A light bulb transfers energy from electrical into light and heat energy. Over 90% of this energy warms the surroundings immediately, so it's wasted energy. And in that case of a light bulb. The kettle also transfers electrical energy by warming, but in this case it is useful energy. The wasted energy in the kettle is the energy that warms the kettle and or the surroundings instead of the water. The kettle is more efficient than the light bulb because its useful form of energy output is heat. Okay, generally speaking, if the useful energy output is heat, it's going to be more efficient. Now, I didn't draw a diagram to go with this, but a lovely diagram might be a Sankey diagram or a picture of the kettle and the lamp and having different energy transfers happening in it. Okay, so if everything is going well at home, take care and stay safe. Bye bye.